Did you get me drinks? Can I have my drinks now? Okay. Huh? Okay. Did you put ice? Thank you. Yeah. Thank you very much. Okay. You can see my slide. There you go. And I'm clear. Is that a yes? Yes, yes, yo. All right. So Crystal, Claire, Quan Line, Quan Lin, Cannoli, Andre. There you go. I see you. So let's start. We finished with the anterior anatomy and physiology, correct? Of the anterior. So we finished it, right? Did we finish? Yes, yes, yes. According to Claire, that's a big yes. All right. So let's continue. So now let's learn more about the cornea. So this is the corneal topography, measurement, and the significance. Okay, so the normal corneal dimension and topography. So review of corneal parameters. So the cornea HVID is around 10 to 14 millimeters, correct? The VVID, what's VVID again?
Vertical visible iris diameter.
Very good choice, very good. So this is your vertical visible, which average of 10.6, which is lesser than your HVID by zero point 0.5 to 1 millimeter. All right. And why is this so? We know the reason, right? Do we know the reason why?
Insertion of the superior rectus.
Okay, very good, Zach. And because of the asymmetrical, right? Cornea, correct? And the asphericity, correct? They're not equal. All right. So that's what it is, as you can see. But, you know, correct, Zach? That's the reason why. You would notice superiorly and inferiorly, that's where the insertion is. Now, corneal thickness, according to clinical studies, about zero point 0.5 to zero point 0.65 millimeters. The gall strand, of course, is about 0.50 millimeters. So if you are to analyze the variation of the central and peripheral thickness, of course, where is it thicker? Of course, peripherally, right? It thickens peripherally. You are knowledgeable about that, right? From the center, it goes flatter peripherally and thicker peripherally. All right. Not only is it flattening peripherally, it thickens peripherally. Mimi is home.
Hi, Mom. Welcome back. How was your walk? You know what's better? Asher packing away his computer and doing whatever he was gonna do with his
Get back to your
Coco.
computer now. And be quiet. I'm in my class. This is my classroom, guys. Respect me. Come on. All right. Sorry, guys. Sorry. Welcome to my home. Zach, this is my home, man. I got you Big Mac. Okay. Yeah, because you promised to buy him food. Okay. Wow. My wife goes to the gym every day. Wow, sana all. I don't have time to go to the gym. I'm working every day. Right, Zach? All right. So far, we're good. Okay. Zach, where is your partner? I don't see him. He's not around. Okay. Let's go. Corneal thickness. And this is done using a pachymeter or the pachymeter. So you have your ultrasonic, the A scan. We can also understand by using the beam splitting device on slit lamp. How thick, right? That's why you can see ABCD when you do your um, external. When you do external, whose hand is that typing? Amazing. Someone is typing. Can you see that? Yeah, she is typing. What is she typing? Yeah. Does she know that I can see her type? Right? All right, let's get it on. Next, of course, refractive index. What is the refractive index of the cornea? As you can see here, 1.376. Yeah, you go crazy. All right, anterior epithelium about 1.4, anterior stroma 1.3, posterior stroma 1.373. Okay, just add them up. Okay, corneal topography. Corneal curvature, as you can see there, this is your radius. Whenever you say radius, we're talking about curvature, correct? All right, so you have a 7.8. So 7.8 is most likely your 44 diopter, correct? Because there's two ways to measure using keratometer. One is the dioptric power, and the other one is the radius of curvature. Am I right? Yep, yep. Okay. So, in early life, we are said that everyone, or mostly, unless there's a defect, are with the rule, astigmatism. With a center of curvature, not fixed value because of eye movement, or in radius varies over repeated measures. Okay, so this is the Gallstrand schematic. Which you use. I believe you guys are also using the schematic. Are you guys using the schematic? Um, is that a big yes? Is that a yes? Is that a no? Yes, yes, yes. All right. So you still see that. So the corneal scleral junction. So the corneal scleral junction, as we all know, is called limbus. Correct? So the other term for corneoscleral junction is limbus. Correct? Am I right? Because it's the junction between the cornea and the sclera. That's why it's the limbus. Okay, assessment of the limbal topography. We make use of slit lamp and the Placido disc. So the Placido discs are, you know, concentric rings varying from smaller to bigger that will represent areas of your cornea. Correct? Okay, so let's find out. Cornea, as we established, is aspheric, and the asphericity is the deviation of the peripheral curvature from the apical curvature, which means from the center, which is the most curved part of the cornea, flattens peripherally. And this amount of flattening is called eccentricity value. Do you follow? Any questions so far? So that's your asphericity. So the conic section, from the word cone. So we have the ellipse or the ellipsoidal, the circle. You have the paraboloid or the parabola, and the hyperboloid or the hyperbola, which is the biggest. So if I am to understand, the amount of deviation will differ depending on the person's anatomy. Right, Zach? Same with our height. Zach is taller than me. Are you taller than me, Zach?
I haven't noticed.
Oh, you have not noticed. But I think you're taller than me. Are you 5'5"?
Taller naman.
Taller than 5'5". There you go. So you are taller than me. There you go. That's why the amount of flattening will vary per percent. So we cannot say that Zach should only be 5'5" like me because we differ, right? Same with the structure of your cornea. So the greater the flattening, of course, the greater the value of eccentricity. So most likely that would be hyperbola. In the circle, on the other hand, because circle is like zero eccentricity, meaning to say there's no flattening. How does it work? It's like this. If this is, I don't know what kind of drawing is this. All right. If this is a circle, which is not circle, not a perfect circle, but assuming that that's a perfect circle, so your cornea flattens peripherally, correct? So this amount of flattening is called asphericity, correct? And that amount of flattening, to be more detailed, is called the eccentricity value. Okay, that's your eccentricity value. Are we clear so far? Any questions? Okay, no questions? All right, wonderful. Let's carry on then. That's why we have to study the conic section, because this represents what? The amount of flattening of your patient, so that you would know the parameter, therefore the measurement, therefore what you will order, right? So as you can see here, the shapes of a conic section, hyperbola has an eccentricity value of greater than 1. Parabola has an eccentricity value of 1. Circle, on the other hand, is 0 because it doesn't flatten peripherally, correct? Zach, do you still follow me? No questions so far? Are we good with the conic section? Did you learn this from your ophthalmics? No. So you're learning it from me? Okay. There you go. So Zach, you would notice the circle. Let's start with the circle again. Circle is equal to 0, correct? Meaning to say, it does not flatten peripherally, correct? But as it flattens, the greater the flattening, of course, the greater the value of eccentricity, correct? Correct? Do you understand what?
Yes, Doc.
All right, very good. So now that you see the eccentricity value, it's represented by a conic section. Whether is it a hyperbola, which is eccentricity greater than 1? Is it a parabola, which is equal to 1? A trapezoidal, less than 1? Or a circle, which is 0? Correct? You follow? Please let me know if you are following, okay? If you have any questions, do let me know too. How about give me something like thumbs up if you understand. All right, I'm seeing it. Nice, nice. All right. Is your camera still on, guys? Okay, because I'm not seeing anyone. Okay. Anywho, maybe it's my internet. All right. So, a conic, yeah, the word cone, conicoid, a revolution of a conic about an axis of symmetry, which is circle is symmetrical, circle symmetrical, right? Because there is no flattening whatsoever. There's no deviation whatsoever. That's why it is circle. That's why if you go in circle, you're like going around and around and around means you're not going anywhere, correct? Okay. Has normals to the surface from an alveoli. Now, the corneal apex, which we also call the cap, right? The point of maximum curvature or shortest radius. Uh, can someone please give me confirmation if you can still hear me and you are getting me? Randale,
Yes, Doc.
one that I can talk to who has has a camera on because I'm not seeing anyone. I need to see. You know, I saw a research. They said online is not effective because you cannot see the gestures, you cannot see the facial expression, and that's exactly why I want to see the faces. There you go. There you go, Randale. Thank you. Now I'm seeing faces. There you go. Good, good, good. All right. So, where is it flattest? It's the periphery. Where is it more curved? It's your apex, correct? Which is the shortest radius. That's why, remember in radius of curvature, the lesser the value, the more curved it is, correct? The greater the value, the flatter it is, correct? All right, learning. Hey, Randale, did you invite me on Facebook? Was that you? I accepted.
Yes, Doc.
Oh,
Thank you for accepting.
of course. Yeah, I accepted. All right, gotcha. Measures of, just want to validate if it's really you. Measures of asphericity. So whenever we say asphericity, it means it's not following that sphere. That's why it's aspheric, because we know the amount of flattening, because it really does flatten peripherally. So that's what you call eccentricity value plus the shape factor and the asphericity parameter. Okay, eccentricity, as I've said, is defined as the degree of peripheral asphericity, or in other words, the amount of flattening from the center to the periphery. Are we clear? Very good. Now you can see here, these are the values. Oblate, you can see that it is lesser than 0. Circle is 0. Prolate is greater than or lesser than 1. Sorry. Parabola is equal to 1. Hyperbola is the one that is greater than 1. I say this again. Oblate is on the negative side of 0, the oblate ellipse. The circle is 0. Prolate is lesser than 1. Parabola is 1. Hyperbola is greater than 1. Clear? All right. So aim of determining the p-value, which is define the eccentricity of the corneal surface mathematically. That's why we solve, right? We make use of the data. We extrapolate and we compute, right? The p-value is defined as the mathematical derivation of your corneal surface eccentricity. And where is this important, Randall?
Well, for determining the asphericity or the eccentricity of the cornea.
Why is it important? You're kidding me. You're just saying what I just said. What is it for? What's the importance? Let me ask it this way. What is the importance of taking a bath?
Para hindi po mabaho.
Very good. There you go. So let me ask you again. What's the point of this getting the value or the eccentricity or the asphericity? Why do you want to know that? That's why my question is why? Why do you want to know that? If you were able to answer why do you take a bath, so that you'll be clean, so you smell good, so you be good, right? So why do you need to determine this? What's the
Doc,
important?
para hindi po magkamali sa ibibigay na size ng contact lens.
Oh, in other words, nasa complex ka na eh. Hindi, Arr, arr. Make it simple. Why do you need it? Nasa mali ka na kaagad eh. Bago ka magkamali, tumama ka naman muna. Ano ang tama? Ikaw nasa mali para hindi pa magkamali. Nasa negative ka kaagad eh. Ikaw talaga, Randall. Go.
Doc, para tama yung sukat.
Ikaw mamalit, tama ka muna. Para tama ang sukat. Di ba? Di kita mo, Randall? That's how you think. You think negatively right away. Para hindi mabaho. Hindi mo pwedeng sabihin mo, naliligo ako para mabango. No. Ikaw talaga, negative lahat eh. Kanina, naliligo para hindi mabaho. Ang nasa isip, mabaho, negative. Ngayon, bakit ano? Para hindi mali. Negative na naman. Ikaw talaga. Alright. Change your point of view. Your POV. Okay? Before you go there, go to the positive first. Anyways, it's all about, I get that. But instead of focusing on the negative, why don't you join me in the positive, right? All right. So, again, why do you need this?
For the right measurements po.
Very good. That's the right answer to get the right measurement of the what?
Of the cornea po.
Of the core. Uh-huh.
Contact lens po.
Okay. The subject is contact lens, right? We need to get the right measurement of the cornea so we can get the right measurement of the contact lens. Very good. Are we learning? See, the way you guys are answering is the same way I can sense how you think, right? All right. Okay. Water break. Let's all drink. Let's drink to that. Okay, very good. Now the corneal asphericity, as the cornea is an aspherical surface, it's ellipsoidal peripherally, and again, it's not necessarily symmetrical. Correct? There you go. I'm seeing Quanlina already. I'm seeing Zach. I'm seeing Andre again. I'm seeing Crystal. Yay, my internet is back. It's back. Da, 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 da. It's back. Da, da, da. I'm so happy you guys are back. Yeah. Am I too much energy, guys? You know what time I woke up? 6 a.m. Actually, before that. But I still have energy. You know why? Hi, Alisa. You know why I have so much energy, Zach? You don't know. Because I am ADHD. Is that other big ADHD? Yay. Because your dad is ADHD. Huh? Oh. Well, just look at your data and that's it. Yeah. Say hi, everybody. I make my data happy. Yeah, they can hear us. No, they can hear us.
How?
Huh?
How?
Ask them. They can hear you guys.
Can you hear us?
We can't hear you. Say, we can't hear you.
We can't hear you.
Can you hear us?
Can you hear us?
No one is talking to you. They don't want to talk to you. I don't know
I
why.
don't know.
You call anyone there. Call Zach. Say, hey, Zach.
Exact.
What's up, bro? Huh? You don't want to say that? Okay. So, ellipsoidal peripherally and not necessarily symmetrical. That's your corneal asphericity. Is eccentricity value of the human cornea is an ellipsoid. So your cornea is ellipsoidal. All right. The cornea is ellipsoidal. Eccentricity values that have been given range is 4.41 to 0.58 with an average of 0.47. All right. Regions of the corneal asphericity or asphericity. Number one is your central region or your corneal cap. So meaning to say, when you are doing your keratometry, you are measuring the corneal cap. Correct? It is your corneal cap or the central region. To be exact, 3 millimeters. Correct? Are we measuring 3 millimeters? Yes. All right. And then we have the mid peripheral region. And then the peripheral region. Of course, as you go away from the center, your keratometer. Wow, can I have some of that? What's that? Okay. Your keratometer may not be equipped. That's why you might think of a topographer. So you can get the full scope from the limbus all the way to the corneal cap, right? From center to the periphery. So here you go. This is the nomenclature. So you have apical zone, which is your corneal cap, the transition, and you have your geometric center. I'm sure you know your metric center. Because when giving RX or your spectacles, you have learned from who's your ophthalmic? Who's your teacher, guys?
Doc Fer po, Doc.
Oh, did he teach you geometric center, the datum system, the boxing system? Guys, do you know what I'm talking
Yes,
about?
Doc. We did it with Doc Olazo
Oh.
during lab.
Oh, there you go. That is your geometric center, right? And then your keratometric limbus. And C for the visual center, D the apical center, and F your limiting margin. So that is your corneal nomenclature. So this, as you can see, Zach, what did I tell you last time? You can explain things by looking at them. Apical center. What comes to your mind? The apical zone. That is the center, right? Because the apex of a pyramid is always the center, right? All right. Which is the what? What was I? Uh, I can't. I have class. Yes, yes, yes. You may eat now. Okay. Quickly, go. Wait, guys. Go ahead. All right. All right, guys. So based on the, can someone explain apical zone? So that's the center. Transition zone. What does it mean? As I've said, if there's a junction, there must be a transition. When you say transition, I'm transitioning from earlier work now to homework, right? There's a transition. That's why it's all about word games, right? That's why I don't have to even check Google to know the definition. I just have to know the words, right? Am I right, Zach? Am I right, Randale? Yes? Do I make sense? Yes? All right. Now, your corneal cap is about 4 millimeters approximately. Okay. Isn't that what we measure from keratometer? What are we measuring in keratometer?
3 millimeters po.
Oh, there you go. Then we're talking about the corneal cap. Correct? All right. So that's what you're measuring when you use keratometer. The corneal cap. Are you aware of that? Is it the first time you hear the corneal cap? Oh, is it? It's the first time? All right. Okay. All right. Okay. And there's a decentration from the word decentered. What does that mean? What does that mean when I say decentered? Like me, my mind is decentered. I'm not focused. What does that mean?
It means it is not the exact center.
All right.
Medyo
That's what
tabi.
centered. It's away from the center. Guys, it's so easy, right? All right. So there's a decentration, which is nasally superiorly. That is the decentration. Under normal circumstance. I'm talking about normal circumstance. That's why if you check the corneal cap, it's more nasal than temporal. And it's more superior than inferior. Are we clear? Is that clear? There you go. Next, the assumptions of the corneal cap. Limited degree of flattening, of course, because from the center, we are assuming that it is the peak of what? The peak of Pikachu? The peak of what? The peak of the apex, right? Meaning to say, that's where the greatest curvature is. That's why there's a limited degree of flattening. Does that make sense, Zach?
Yes po.
Right? I mean, sometimes, um, whenever I see something like this, I go like, duh. Of course, there's gonna be limited flattening. Why? It's the area where it is greatest curve. Correct? So if you say that you are at the greatest curve, the flattening there must be less. Correct? All right. Very good. And then regional curvature variation is insignificant because we vary. We are not the same, right? Correct? And K reading is not at the geometric center. The mid peripheral, because we are already understand that we are decentered. Where's the decentration again? Let me see if you remember.
Nasally and superiorly.
Very good. Very good. Very good. That's normal. It is normal to be decentered, okay? Very good. Now, mid-peripheral, not alignment with the monocurve. Because in monocurve, there's only one from the word mono. Very good.
One curve.
Huh?
One curve only. One
Exactly.
curve.
But you already know that your cornea is not a one curve. Correct? Because it is aspheric. Another redundancy, Randall, right? It's like, huh, it's already given. I already know that from the get-go, right? Based on, why did I say it's not going to be aligned with a monocurve? Because a monocurve, you are saying if my cornea is circle, then I go for monocurve. But my cornea is never circle, correct? Because it flattens where?
At the periphery.
Very good, very good, very good. So does that make sense? It makes sense, right? I mean, it makes a lot of sense. When you see something, you interpret it like so clearly in your mind that you understand, that you don't need to memorize because you understand. Correct? Is that right, Quan Lin? Right. Next, mid peripheral region, the region of greater flattening. There you go. Which is again Randall, Zach, Alisa, Quan Lin is logical based on redundancy again. Because why? We established earlier that the greatest curvature is where?
At the apex. At the corner.
Okay. If at the apex, if you go away from the apex, what's happening?
It will flatten.
Very good. Isn't that like logical? You don't have to tell me that. You don't have to put here region of greater flattening. Duh. Right? Makes me want to say duh. Right, Zach? This is a big duh. I already know that. Right, Quan Min? Are you learning, Quan Min?
Yes, Doc.
Can you cope with my energy? No? Oh my gosh. I'm 53. All right. Let's go. In the evidence of negative asphericity. There you go. That's your mid-peripheral region. So, if we're talking about peripheral region, okay. Oh, I should have like clicked later on. I should have asked you first. Okay, this is 90% of semi-meridians have the positive asphericity. The remainder zero or negative, which is nasal and superior nasal asphericities, were greater than other semi-meridians. Because we understand, based on what Zach said earlier, it's toward nasal superior, correct? All right, there's a deviation, there's a decentration, right? Correct? Correct. Give me something, guys. Yes. There you go. Thanks. Thanks. Gotcha. Measurement application, estimation of refractive error, assessment of pathology, contact lens fitting, assessing effects of contact lenses, and refractive surgery. So, meaning to say, this should have been your answer, Randale, when I ask you, why do you have to understand the cornea, the amount of flattening, the eccentricity value? Why do you need to understand that? Because I need to get the right measurement for contact lens fitting, correct? I need to have an estimation of the refractive error. Why? Can someone explain that to me? Quan Lin left us. Okay. Zach.
Doc, the cornea is the strongest refractive surface. So, if there are errors or parang inconsistencies sa curvature that are out of the normal, this is indicative of the presence of EOR.
And why? I taught you this. Simplify that. You answered as if you're reading something. I want you to answer me as if it comes from your layman term. Like, I do understand that. I'm like, how are you going to explain it to my 1-year-old baby? You know it. You know it. I already explained that last time. But anyways, you can use your own word. Go ahead.
For cornea, Doc, the greater the curvature po, di ba? The stronger the
There
convergence.
you
So,
go.
if you measured po the cornea na more curved, the higher tendency of having myopia. Pag flatter naman po the other.
Oh, very good, Joyce. Did we discuss that last time?
On our first meeting po, Doc.
Correct. Correct. Tell Zach. Zach, where were you? Go, tell Zach. Zach, do you remember that? Where were you? On the 9th of September. Zach, do you remember we discussed that?
Yes, the
Now you remember that you can say it in that way instead of reading a Google answer, right? I mean, it like from the get-go, it's a lot easier to say like, yeah, of course I can estimate the refractive error. The greater the curvature, the greater the power. The lesser the curvature, most likely towards the, what kind of error of refraction is this? Hyperopia, correct? The greater the curvature, the greater the myopia for sure, right? Make sense? Very good. All right. Okay. So another thing here is assessment of pathology. Of course, when you see if there's any pathology, any abnormality, any deviation from the norm, we can simply say, I know that there's an ectasia. Why? Because I measured. How would you know that there's ectasia if you didn't measure, right? How would you know that Zach is so handsome if you did not turn on your camera? Am I right? Am I right? Does that make sense? Does it make sense? See, Anissa said yes, right? That's why back in the days, if you are trying to hook up with someone and the only thing that you hear is the voice, well then good luck, right? Good thing now you can FaceTime. Make sure. I don't know if you've seen from Netflix, there are some of those, what is that? The hackers or something like dating wherein the person is asking for this and that without even seeing the person's.
There
Yeah.
was a hacker who hacked an alarm tower and played the SpongeBob theme song on it.
Oh, really?
Mhm.
Okay, let's talk about SpongeBob. Ladies and gentlemen, I got SpongeBob in my house. Okay, okay, I'm in my class. I need respect. All right, thank you. Sorry, guys, intermission. But do you understand what I'm saying? All right. Assessing effects of contact lenses and refractive surgery. Everything makes sense, correct? Right, Zach? Everything makes sense. Alisa, there you go. Thank you. Randall, you still with us? Gotcha. All right. Now, problems of measurement. For keratometer, it's the fixation. That's why I would always ask Zach. Remember, I would tell you, do this fast and accurately. Meaning to say, as soon as you establish your patient to sit down, to put their chin in their forehead so that you'll have a plane to measure. From there, stop moving, stop, just hold it, blink, blink, and then hold, don't move, let me capture, that's it. Because the usual problem is fixation, correct? Because as soon as the patient starts moving, you will have variation, correct? So, Zach, me being ADHD, do you think you can catch me? Huh? Can you catch me? Huh? Can you catch me? Can you catch me? Huh? What do you think? Huh? Can you catch me? No, exactly. Right? Because I keep on,
Moving.
there you go. I keep on moving. Now, the accuracy is already questionable, right? Another thing is the instrument error when it is not calibrated. What thing do you know that needs calibration? Anyone? Example of calibration. Huh? What? Something to calibrate. What are the things that need to be calibrated? A
Weighing scale.
very good. A weighing scale needs to be calibrated, or else you will find different findings, and that might ruin the accuracy of the tests, right? Very good. Randall is nodding because he is agreeing, right? Correct. As simple as that. Next, upper.
Doc, others have error of reflection. I don't have. So there's a difference. They might need to adjust the instrument.
Operator variability. Okay, like I have an RX, the other does not have RX. So that's why you have your ocular piece, right? So you can change the clarity. Okay, but what other operator variability are we talking about here?
Doc skill and experience.
Yes, go ahead.
Yung parang experience ng operator on how long they've been, performing procedures.
Correct. Like you would notice, my finding is not the same as yours. And it will depend on, again, mentioned by Zach, the great Zach, is your skill. If you're not skillful, most likely you're bound to make mistakes, correct? Oh, Randall understands that. Very good. The amazing Randall. The great Zach. The missing Randolph. Okay. Where is Randolph anyways? I never see him. But he's just there, right? Zach? He's there? All right.
Yes, so Doc is present.
All right. All right. Okay. Sources of error. Instrumentation. Assumption. Because we're not from assumption. We're from CEU. Are we assumptionistas? No. We are scholarians. Okay. That's my last joke. Anywho, because we assume too much, right? We assume. That's the assumption. Right. And uses for axial theory. And it assumes focal length, which is your image distance, and object source comes from a flat plane. Well, question is the forehead and the chin rest are in the right position? So you know that you would have a problem, right? Not to mention reproducibility. Once trial 1 is taken, you are most likely to have a deviation for the trial 2. Agree, disagree? Thumbs up means agree. Yes? All right. And assumes the cornea is a spherocylinder. All right. Now, from the operator, that means it's me, it's you, it's all of us. How we focus. Yeah? The focusing. That's why I would ask you always check your patient. Are your patient still in the right position? Friend. And you know how he does that? He accommodates forcefully to alter the findings. That's why you would notice the best thing to make sure that accommodation is relaxed is by what?
Cycloplegia.
Correct. It's called wet refraction, right? Paralyze it. Because a plus lens may not be enough. Though a plus lens helps relax, but there's still that remaining action of the muscles, right? That can be hidden. But when you go for action, what's so funny, Zach? Am I funny enough? Yes? Are you learning?
Yes
Really?
po, Doc.
Okay. And then we have the alignment errors and the orientation of instrument. As long as we're having fun and learning things, I'm all good. Right? Am I right? Is Randolph messaging you right now, Zach? I knew it. I nailed it. I knew it. All right, let's go. Okay, next. Source of error is the patient. Why is it the patient? Why is it the patient? Why the patient? Why the patient, guys? Why the patient?
Because sometimes, Doc, the patient have ADHD.
Oh, just like me. Very good. Wow, you are smooth killer. All right. Okay. Corneal distortion cause Myers. Fixation steadiness. That's the answer. Correct. Because the patient cannot be steady. All right. Instrumentation for corneal topography. Methods of measurement, you have optical, which is done by reflection, optical profiling, interferometry, and the what? French? And what am I? French? Zach, do you speak French? Pardonnez-moi. All right. Excusez-moi. Ashi, Ahia, sing to us the French song. When I know it's Italian, my bad. It's Italian. That's amore. Yes. All right. It's Italian. Sorry, my bad. Did you did you hear my son saying, Zach?
Yes po, Doc.
See? That's the kind of household you have once your dad is ADHD. All right. Always happy. Right? Always happy. Yeah. Okay. Next, you have your contact methods by casting and molding, ultrasound, and trial contact lenses. From the word contact, the key word there is contact. Correct, Zach? Correct, Randale? All right. Next. Optical reflection is a non-contact, non-invasive, rapid data collection, most convenient, and output readily used. Example is a keratoscope or the keratometers that you guys are using, correct? Andre, I want your microphone. I like that. I like your setup. Is that a microphone setup?
Yeah, yes, Doc.
I like it. Let me know how to buy that, okay? I want to have that too. I like it. Okay. Next, methods of measurement by optical profiling or your 2D. If there's 3D, there's 1D, and there's 2D. And what do we understand about the difference of 1, 2, and 3D? Who can answer? What's the difference between 1, 2, and 3D? When you say 3, three-dimensional, meaning to say you don't see things flat as flat, right? You see space, you see measurement, you see how far. That's why if you don't have stereopsis, you don't have depth perception, most likely you will have problems too, right? Correct? Does that make sense? In appreciating, that's why, as they say, people who does not have 3D, when they go and watch at IMAX, they never appreciate, right? Because they don't feel the 3D effect. They don't appreciate it. I have my former teacher back in, when was Doc Eric in CEU? What, 10 years ago?
5 years ago?
5 years ago? No, more than that.
7?
Yeah, he cannot appreciate IMAX because of his condition,
What's his condition?
high minus.
I don't know.
So he cannot really appreciate much of that. Okay. So
Can you get your scooter?
next, we have optical profiling 3D. Again, I was just saying, of course, 3D is more on the appreciating the full dimension. That's why in I don't know if you're familiar, when my wife was pregnant, there's what you call ultrasound with 4D. So you can see also the face, you can see the hands, because you see more detail, right?
Wait, let me add my timer.
Correct? So the higher the D, the higher the details, correct? Is that right? Does that make sense to you? No? No, Zach? No? You don't believe that? What do you think? No? The higher the D, the higher the details? Yes? All right. There you go. See? Next. Contact method, as I've mentioned, from the word contact, it sits in contact. So, contact may distort topography, time consuming, on some method only qualitative, and data can be difficult to interpret, such as using a mold or cast, such as ultrasound and trial contact lenses, which you guys are familiar, right? Now, using corneal topography, they make use of this Placido disc, the photokeratoscope, you have your keratometer, and the computer-assisted topographic analysis. So this is how it looks like. It has a wide field of view, more complete Myers. Not only do you see the central 3 millimeters, you go beyond that. Okay? And it is qualitative. So this is an example of your Placido disc. It's a concentric ring from small to big, because you already know you want to measure from center all the way to the periphery, right? So this is a topographer. Do Do you know that we have a topographer in school? Were you able to use the topographer?
Yes, Doc.
Oh, very good, very good. Does it have this Placido disc?
Yes po.
All right, very good, wonderful. Okay, so the principle there is, of course, the first Purkinje image reflection of bright rings. It's the rings, okay? With central viewing through magnifying lens and outer rings subtend to a wider angle. Okay. From so again, you'd see the elliptical when you have astigmatism. You see distortion when there's irregularity such as scars or those with refractive surgeries or those who undergone LASIK or those who have ectasia. It's going to be irregular and asymmetrical to the point of advanced keratoconus. Correct? Correct? Is that correct? Time check. Are you still with me? All right. So let's end here. So this is a good example of a what?
Water. I took water out and drank it.
What? What is this? Can someone explain what you're seeing? How are you going to interpret this?
Distorted
Go ahead.
Myers po.
Sorry?
Distorted Myers.
Distorted. So if it's distorted, what's your interpretation?
Ectasia po.
Huh?
Ectasia.
There must be an irregular cornea, right? Such as ectasia. Okay? Because it's a giveaway. It's the concentric ring is not perfect. It is distorted, right? Correct? All right. But one downside of a tear dependent machines, it could be the tears drying up, right? That causes distortion. So you have to understand there are machines that are tear dependent. Okay? But usually this represents very good. Very good, Brent. Very good. So I end with this. Guys, happy lunch, happy dinner, happy what do you call that means? Like late dinner, like midnight snack. Arrivederci. Arrivederla. Taijian. What else? Uh, what else? Sayonara. Sayonara with an Italian accent. Ciao bella. Huh? Adios patria adorada. Tata. Goodbye. See ya.
Thank you po, Doc.
Good night, good night, good night. Good night.
Thank you,
Thank you, Doc.
Doc.
Thank you,
Thank you
Doc.
po,
Thank you po,
Doc.
Doc. Thank you, Doc.
Thank you, good night. Good night, everybody. Good night. Good night. Good night. Good night, sir.